So hello everyone, welcome to my YouTube channel. So today I'm starting my playlist for data science. So the first and most important part is Pandas. So Pandas is a Python library and it is used to analyze data, and it has various functions for analyzing, cleaning, exploring and manipulating data. So today we will discuss from scratch to pro level. We will discuss everything how we can use pandas for working with our data sets. So let us begin. So the first thing is you should know what is a data frame. A data frame is a 2 by 2 array or a table with rows and columns. So data frame is basically used to represent your data set in pandas. So let me show how we can create a data set using pandas. So first of all we have to import library pandas, import pandas as pd. So I have to run this. So right now this is importing my library pandas. So this pd is the alias of pandas. Now let us see how we can create a data frame. So let me create one dictionary of Python. So this dictionary is having first key as distance, and distance is having values 420, 380, 250, and the second key is duration. So this duration key is having values in the form of list again. So this is the duration key and values. So right now I'm having a dictionary data and it is having two key value pairs, and now I will create a data frame using this Python dictionary. I hope you guys have basic knowledge of Python before watching this video. So I will load the data into a data frame object. So df is representing my data frame, and there is one method inside pandas library known as data frame, which is used to load the Python dictionary in the form of data frame. So now let us see. So I have written the code. Now I am executing this. Now you can see that I have successfully created the data frame using a Python dictionary. This data frame is having two columns. First one is distance, second one is duration, and it is having 3 rows. This data set is created now. So mostly when we are working with the huge data sets, we don't create the data sets by using this method. We read it through different sources. It can be an Excel file or a CSV file or a JSON file, but the most commonly used file is a CSV file. So right now I am having one CSV file in my PC. Let me show you datas.csv. So I think it will not open in this way. Let me try one more way. Okay, so I am having this datas.csv file which contains comma separated values inside the Excel sheet. Let me show you. Now you can see that this is my Excel sheet, and it is containing 4 columns: duration, pulse, max pulse and calories. So it is having 169 rows. You can see downwards. There are 169, almost 170 rows. So let us go, and now I will tell you how to read a data frame by using how to read a CSV file and store it as your data frame. So there is one function known as read underscore CSV. This is used to read any CSV file. So I will mention the name of the CSV file. So name of my CSV file was datas.csv. You can see here datas.csv. So I am reading the name. I am reading this data df.csv file. It has been successfully read. Now I will show you what are the main rows. So df.head method, this head method is basically used to return the first 5 rows of the data frame. So it has given me the first 5 rows. So this 0 1 2 3 4 is showing the index of the rows. So this is 0th row, first row, second row, third row, fourth row. So in the similar way, there is one more function, df.tail. Df.tail function is used to return the last 5 rows of the data frame. So you can see that it has given us last 5 rows of the data frame. Now let us move ahead. Now in order to see what kind of data types are present in our data frame, we can use a method known as dtypes. So if I will write df.dtypes, it will give me the name of the data types for each column. So you can see that the first column duration is having data type int64, and pulse is again having int64, then max pulse, then calories. So this is a method which is used for checking the data type of a given function, given data frame. Now let us see how to change the data type of a given column from one data type to another data type. So let's change the data type, and I will change the data type of this pulse column from int to float. So I will write df dot pulse dot equals to df dot pulse dot as type, and inside this I have to mention the name of the data type in which I have to convert this pulse column. Earlier it was int64, now I am converting it. So now let us again check what are the data types of the given data frame. So I will have to use this. So now you can see that the data type has been changed. Earlier it was int64, now it is float64. So now let us see some commonly used functions that are used for aggregation. So let us see firstly let us see the min function. Min function is basically used to return the minimum value of a particular column. So you can see the minimum value of pulse column is 80. Minimum value of a column. So after this we will see another functions. So df dot duration dot max, this is used to return the maximum value of a column. Then in the similar way we can write df dot duration dot mean, it will give us the mean value of a column. Next is df dot pulse dot std, it is used to return the standard deviation of a particular column. Oh sorry, it was my mistake, I have written e twice. So now you can see the standard deviation of pulse column is 14.51. It is used for the standard deviation. Now let us see how we can find the median. In the similar way, we can find the median of a column also. For that, we have to use median function. So you can see this. I have successfully found all the statistical metrics. Now there is one more commonly used function which is really helpful, that is df.describe. Describe function is used to describe the entire data frame. So in this data frame you can see there are 4 columns. First one is duration, second one is pulse, max pulse, and calories. Now this on the left hand side you can see there are some labels. First one is count. It is showing that there are 169 number of rows in the duration column. Like this, all the columns are having some set of records. So duration column is having a mean of 63.84. Duration column is having standard deviation of 42.29, and the minimum value in duration column is 15. Maximum value in duration column is 300, and this 25 percentile is showing that 25% of the values in the data frame are below 45, and 50% of the values are below 60, and 75% of the values are below 60. In the same way, we can observe the values for other columns. Now let us see the next important function, which is a transform function. Transform function is basically used to apply transformation activity on any column in the data frame. For example, if I want to transform my pulse column, so I have to use this transform function, and inside this I will be giving one function, lambda expression, and I will multiply each record by 10. So what will happen after this? This x is representing each value inside this pulse column, and it will multiply each value with 10 according to my lambda expression. So let me show you what is the result of this. So you can see each value is getting multiplied by 10. Now let me show you how it is, whether any change has been done in the data frame or not. You can see the original data frame, there is no change, because I had not added the value to the df.pulse. In order to reflect the change in the main data frame, I will have to add the changes to the main data frame. So in order to do that, I will write df.pulse. I will create a new column instead. So I will create new df new equals to df.pulse dot transform, and inside the bracket I have to mention lambda expression. So now you can easily observe the change. Let me show you what is the data frame looking now. So you can see now one more column has been added inside my data frame, and in the pulse value we are having the same original column, but I have added one more column in which each value is multiplied by 10 with the pulse column. So you can see here 110, 1100, 117, 1170. So in this way, every column is having values multiplied by 10. So now let us observe next function, which is filter function. So in order to explain you filter function, I have to use another data set. So I am changing the value of df to df pd.read.csv. I have one more csv file. The name of that file is data2.csv. Let me show you that file as well. So data2.csv file is present over here, is opening. So this data2.csv file is having two columns only, and the first column is country, second column is population, and there are 9 records. There are 8 records except this header, and 8 records in country column and 8 records in population column. So let me import this as a data frame. So I have written it, and now let me show you. So you can see that I have imported my data frame successfully, and now I will show you how to use filter function in this data frame. Filter function is basically used to filter a particular column from the entire data frame. So let me show you df.filter. So we can write here items. Items basically represent the name of the column. For example, if I want to filter only one column from the entire data set, like country, so it will give me one column only. So in this way we can use filter function, and we can also use the like operator inside the filter function. Let me show you that as well. For using like operator, we have to use df.filter, then like equals to pop. So what this function will do, it will search for pop inside the columns. If any column is having pop in its name, then it will return that particular column. So you can see that in my data frame only one column was having pop in its name, so it has given me this particular column. So this is how this filter function works. Now let us move forward. How to concatenate two data frames. So concatenation is basically how we can join two data frames together. There are two ways of joining two data frames. First way is joining by joining with the column axis, or joining with row axis. If you are joining column axis, the number of columns will increase, whereas if you are joining with the row axis, the number of rows will increase. I will give you both the examples. So let us start. So in this I will be using my original data frame that I had shown you earlier. So I am reading my CSV file, and the name of that data frame was datas.csv. So I have created one data frame, so I will show you that. So right now it is having 169 rows and 4 columns. So I will create one more data frame, similar data frame. So I will name that new data frame as df2. df2 equals to df, so both the data frames will be having same value. So I will show you how we can concatenate two similar data frames. In this example we can concatenate two different as well, but I am showing how to concatenate similar data frames. So let me show you. For doing that you have to use concat function. You have to I am creating one new data frame, df3. So we will use concat function. Concat function will take two arguments. First one will be the name of the data frames that need to be concatenated. So my first data frame was df, and my second data frame is df2, and I have to mention the axis, where axis equals to 0 represents rows and axis equals to 1 represents column. And if I will use axis equals to 1, it will increase the number of columns in my data frame. Let me show you. So now you can see my df3 is having 8 columns because I have used axis equals to 1. Now let me show you how we can concatenate the data frames on with axis equals to 1. In order to concatenate data frames with axis equals to 0, let me show you that as well. df4 equals to pd dot concat. It will take the data frames df comma df2, then I have to mention axis equals to 0. Now you can see, you can print the output df4. Now we will discuss what is a drop function. Drop function is basically used to drop a particular row or column from a data frame. Right now my data frame df is having 4 columns, so I will show you how to drop any column from this data frame. So let us see. First of all, I will show you how to drop a single column. df dot drop, then I will mention the name of the column inside single quotes or double quotes, whatever you want, and then I have to mention the axis. Axis is very important. If you will not mention the axis, so it will not work. Axis equals to 1 is representing that pulse is a column, so I will mention here df dot drop pulse. So it has given me three columns only in the data frame. So now we will see how to drop multiple columns. In order to drop multiple columns, we have to give df dot drop, then columns, then this column should be a list of name of the columns that you want to drop. For example, if I want to drop 2 columns, pulse and duration, and I want to mention here axis equals to 1, so I will do that. So you can see both pulse and duration column has been removed successfully. Now if I will see my original data frame, you will see that no change has been done in that data frame because I have not done any in place change. In order to make in place changes, we have to use one more thing. I have to use in place. I will give one more argument, in place equals to true. So after giving in place equals to true, you will observe that now the changes has been made at in place. Now if I will see df, you can see only two columns are left. So in this way, if you want to make any change to your data frame, you can use this in place equals to true, but these changes will not be reversible. So make sure you are doing it properly. Now let us see next thing, drop NA. So in order to use drop NA, I will be using another data frame. So I will show you that data frame which is having null values. So the name of that data frame is data2.csv file. So I will import another data frame df equals to, so this is my data2.csv file. You can see here. Now this is datas.csv. I will show you here directly. df equals to pd dot read underscore csv. Then I will mention over here data2.csv. Okay, So sorry, so I will show you this df. So I think I have imported a wrong one. The right one must be data3.csv. So I will have to make the change, data3.csv, then df. So now you can see that I am having null values. These are null values. NaN is basically showing that there are missing values in your data set. So in order to check how many missing values are there in my data set, I will use one function. I will show you how to check how many missing values are there. df dot is null dot sum. Outside this df dot is null dot sum. This function can be used to check how many values are not available. So right now you can see that 151 values are not available in duration, 154 missing values are there in pulse, and 155 missing values are there in max pulse, and 155 missing values are there in calories. So how to deal with the missing values? So in order to deal with this, I have to use one function, drop na. Drop na is basically used to drop the values. So if I will use this drop na function, it will drop all the rows having any null value. So if I will show you this, so it is giving me only these rows back which are not having any null value. So if I want to mention some condition like which rows needs to be dropped, I can mention that as well. So we can mention here the axis. Like if we want to drop the rows, we can mention axis equals to 0, and there is one more argument how. If I will mention any, so it will drop all the rows having any null value. So it will give me the same result back just like I got earlier. But if I will mention here all, so it will drop only those rows which are having all null values. So it will give me more records. Now you can see that this row was not dropped because it is not having all null values, it is having one value which is present over there, so it was not dropped. So in this way you can utilize this drop na function. But instead of dropping the value, you can fill the null values. So in order to fill the null values, we can use this fill na function. So this fill na function is very important. So let me show you how to use this. So first of all, my df is having right now 169 rows and 4 columns. So let me show you how to fill this null values. For example, if I want to fill my duration column with median value, so I will write over here df dot duration equals to df dot duration dot fill na. Then in the bracket I will mention what should be filled inside the missing values. So I will write df dot duration. Oh sorry guys, it should not be there. So I will write df dot duration dot fill na. In the bracket I have to mention the value. So I am mentioning the median value. So it will replace all the missing values with the median values, and I will place over here in place equals to true in order to reflect the changes to my original data frame. So if I will run this, then you can see in your data frame that all the values has been changed with the median value. So you can see your duration column, it is completely filled now. If I will use df dot is null dot sum, so now you will see that duration column is having 0 missing value. So we have used this fill na function to replace all the missing value inside the duration column with median. So I hope you understood the concept of fill na. So now let us move to indexing in Pandas. So indexing is very important, how to grab a particular section of data frame. That thing can be done with the this indexing. First of all, I will change the data frame here. Df equals to pd dot read underscore csv. Then I will mention the name of my data set. Then after that I have to for example, this data frame is having right now four columns and 169 row. For example, if I want to grab only 2 columns instead of getting all 4, so I can mention over here inside this pulse, inside the square brackets, I can mention the name of my columns which I need to grab instead of having the entire data set. So like this I can mention for getting multiple columns. If I want to get single column, I will remove this double square brackets, and instead of that I will use a single square bracket. So you can see it is giving me single column only, pulse column. So this was about indexing in Pandas. Now there is one more function which is lock function. So LOC function is basically used to grab a particular number of rows and columns from the complete data frame. The syntax is lock, then we have square brackets, then we have to mention the rows and columns. Let me show you how it works. So first of all we have to write df.lock, and then we have to write the number of columns, number of rows, then number of columns. So this is showing we are using if we are writing like this, it is showing we are using all the rows as well as columns. So if I will run it, it will give me all the rows as well as columns. And if I want only first 3 rows, so I will give over here 0 to 2. I hope you understand slicing in Python, and the concept is almost similar to that. So if I will run it, so you can see that I have got only three rows, because I used from 0 to 2. The index is going from 0 to 2. Here the index, the last index is inclusive, whereas if we use in Python, the last index is not inclusive, it is inclusive. Now I will show you how to grab particular columns only by using this lock function. Now in order to grab only particular columns, I will use for example, I want to have first 5 rows, so I will give the name of the columns. If I want only pulse column and duration column, I will give the name of duration column. If I will run it now you can see that I have got only 5 rows and 2 columns only. And after that we can also give the condition inside this lock function. So I can write like this, df.lock, then the condition is df.duration should be greater than 120, and I want the columns only duration column to be there. So I have mentioned a condition. This is my condition inside the lock operator, and this is my name of my column. I can mention any number of column over here. So you can see only those rows are returned which are having duration greater than 120. You can see all the rows are having duration greater than 120. We can try one more example. df.log and df.pulse equal to 150. Pulse should be 150, and columns I want only pulse. So let us try this. So only two records are having pulse equals to 150. So this was all about the library of Python Pandas. I hope you really enjoyed this video. So soon we will start complete complete playlist on machine learning. So thank you so much for watching. Please like, share and subscribe if you like.